hydrogen atom travels high within the outermost layer of the Earth's atmosphere. This particular atom first entered the exosphere millions of years ago, and during its tenure on Earth, it spent time in the waves of the Atlantic Ocean, the ground soil of the Amazon, and even the steam rising off a boiling pot of spaghetti. But today, traveling 30 times faster than the speed of sound, it overcomes the Earth's gravitational pull and escapes, joining the roughly 90 tons of material that leak out of our atmosphere each day. This daily whale-sized atmospheric loss is just one example of how the Earth is leaking. Atoms, energy, and molecules seep from one layer of the planet to another, and for Earth, whose stability is necessary to sustain life, these leaks can seem troubling. To better understand the extent of the planet's imperfect plumbing, and when it becomes a problem, let's visit two more leakage sites. Our second spot takes us to the Earth's surface, to a field in central Appalachia. Below, a 1,500-meter deep shaft connects an oil reservoir with the Earth's surface. The oil supply here is dried up, leaving the site neglected and abandoned. But this underground reservoir also houses the potent greenhouse gas methane, which continues to travel up the shaft and escape through cracks and loose pipes. This leaky well joins the more than 3 million abandoned wells scattered throughout the US that collectively emit, by lower estimates, 280,000 metric tons of methane each year. Our final leakage point takes us deep within the innermost boundary of the Earth, the core. Heat, originating from the formation of our solar system, drives the rotation of liquid metal around the solid inner core. The motion, in turn, creates the planet's magnetic field, a barrier that protects it from cosmic radiation and solar wind. But the core isn't perfectly insulated, so heat constantly leaks, escaping to the surrounding mantle and driving plate tectonics and magmatic activity. As a result, the core's outer molten metal is slowly solidifying. Once fully cooled, the magnetic field will disappear, leaving us exposed to the sun's harshest rays. The Earth clearly has some cracks and bleeds. Should we be worried? Thankfully, the immediate risks of our hydrogen leak are low. At its current rate, it'd take over 150 billion years to lose all our hydrogen to space. The same goes for our core leak. Scientists estimate the core won't completely cool for another 700 million to several billion years. Methane emissions, however, have the power to alter our Earth's climate within the next decade. The gas's unique structure efficiently absorbs energy radiating off the Earth, trapping it in the atmosphere as heat. This gives methane incredible warming potential, 86 times that of carbon dioxide. The impact of methane escaping from abandoned wells in the US is comparable to burning 10 billion pounds of coal each year. As abandoned wells in most of the world's top oil producers have yet to be extensively counted or surveyed, the global emissions of all abandoned wells is likely much, much higher, and they join the estimated 570 million tons of methane emitted by other anthropological and natural sources each year. Beyond their climate impact, these unsealed wells can leach methane and other toxic gases into nearby groundwater, contaminating drinking water and impacting local ecosystems. Luckily, non-producing oil wells can be plugged by pumping cement into their depths. While many state and federal governments require oil and gas companies to plug defunct wells, plugging comes at a high expense, so companies have historically dodged policies. For decades, these leaky, low-producing, and economically non-viable wells were sold off and abandoned. It's clear that oil and gas companies won't fix this problem on their own. It'll take concerted governmental efforts such as placing high fees on methane emission and coordinated oversight on plugging to make sure companies are held accountable. But the problem starts before these wells are abandoned. Within the US, active oil and gas production emits massive amounts of methane. about 28 times that of abandoned wells. The best way to eliminate this leak is to stop drilling oil and gas wells in the first place.
But how do we reduce our reliance on oil? Visit ed.ted.com/Earth School for an action guide that shows you how you and your community can be most impactful. One option? Solar energy. Learn whether or not you can save money by switching to solar with this video.